Let's go ahead and begin our next lesson on the introduction of fractions. We're going to need our basic supplies, which include our composition notebook, a couple of color pencils, and our pen or pencil. We are going to need a small sheet of color paper. In fact, I'm just going to use some sheets of my Post-it notes. And of course, we need our scissors and our glue. As we begin this lesson on fractions, we have to remember that we teach fractions just like any other topic. They work with concrete objects such as pattern blocks, fraction strips, or paper folding. Then they move on to the pictorial, in which they draw pictures to represent their fractions. And then in the abstract level, that's where we perform our fractions using the traditional algorithm. I was curious as to when they start teaching fractions, and it's interesting to note in looking at our TEKS that in second grade, the students are asked to recognize and represent fractional units and communicate how they are used to name parts of a whole. In second grade, they're working with halves, fourths, eighths. In letter C, students use concrete models to count fractional parts beyond one whole using words and recognize how many parts it takes to equal one whole. And again, in letter D, they're looking at examples and non-examples of halves, fourths, and eighths. In third grade, the students are looking at denominators, at fractions that have denominators of 2, 3, 4, 6, and 8. They're using concrete objects, still with concrete, and they're moving on toward pictorial models, including strip diagrams and number lines. In letter C, they are looking at a unit fraction. We'll talk about that in our definitions. And letter D, they're going to compose and decompose. Compose and decompose fractions. Fourth grade, they're already adding and subtracting fractions with equal denominators. But notice they're not necessarily doing the traditional algorithm. They are still using objects and pictures along with the traditional algorithm. In fifth grade, they're continuing to add and subtract fractions with unequal denominators using objects, pictorial models, and the properties of operations, or the traditional algorithm. Letter I, they're beginning to work with multiplication, and letter J with division. Okay, let's open our notebook to the next available page. Okay, so let's look at some vocabulary terms in our lesson. Now I do have a lot of room on this previous page, so I'm just going to continue from there so I don't waste a lot of space. If you have a little space, you can start at the top of the next page, and I'll just label this as Intro to Fractions. Go ahead and include the date, and of course, number the page across the top. So let's begin with our first term, which is fraction. A fraction is part of a whole. Part of a whole, or part of a group. Part of a whole or group, or a group. The top number in our fraction is the numerator, and the bottom number of our fraction is our denominator. The numerator tells us how many parts. And the denominator tells us the total number of equal. Make sure you include the word equal parts. Okay, so when you're looking at a fraction, the denominator is going to tell you the total number of pieces. The numerator tells you how many you're referring to. If you're looking at 2 out of 4, perhaps you have a circle and it is divided into 4 regions or 4 sections. And we are going to shade 2 of them. It could be any 2. And so I have 2 out of the 4 that are shaded. So the denominator tells me all the pieces that the circle was cut into. There's 4 pieces. And the numerator would be 2. Let's say 2 red. 2 of the 4 sections were shaded. Okay. Let's look at a unit fraction. A unit fraction is a fraction whose numerator is 1. 1/2, 1/3, 1/4, and so on. And so the numerator is 1. And we'll go into more depth later as into all these different topics. Right now we're just trying to get some basic definitions out of the way. Numerator, denominator, part over whole, a unit fraction, the numerator is always 1. So here we have some fraction strips, and notice that all of the fraction strips are the same length. Whenever you're referring to fractions, they must be the same length or have the same area. So I have 1 whole length, then I divide it into 2 parts, which is half, then I divide it into 4 parts, and all the way down to 8ths. Decompose. Remember that decompose means to break down. To break down or break apart into the sum of its parts. For example, we have 5/6. Now, if we have 5/6, there are several ways to decompose it. Sometimes I have seen a number bond that looks like this. And so these two have to add up to 5/6. So this could be 3/6 and 2/6. And so you could say 3/6 plus 2/6 is equal to 5/6. So there are a lot of ways to decompose. Now, in some instructions, they'll say decompose to the sum of the unit fractions. Decompose to the sum of its unit fractions. So if we have 5/6, that is going to be 1/6, 1/6, 1/6, 1/6, and 1/6. So decompose means to break it apart. We can set up a number bond to show this graphic organizer to show the relationship of how the 5/6 is split apart. And you could use different combinations. I could have a 5/6 over here. And let's put 1/6 and 4/6, as long as it adds up to 5/6. However, if it specifically asks for unit fractions, then the numerator must be 1. 1, 2, 3, 4, 5. I have 5 unit fractions. Okay, the next term is proper fractions. A proper fraction is a fraction in which the numerator is less than the denominator. A fraction in which the numerator is less than the denominator. We'll go through and highlight our key terms. An example of a proper fraction would be 2/3. An improper fraction is a fraction in which the numerator is greater than or equal to the denominator. Is greater than or equal to. Is greater than or equal to the denominator. An example of an improper fraction would be 5/4. The numerator is larger than the denominator. An improper fraction is greater than or equal to 1. Is greater or equal to 1. A mixed number a number composed of a whole number and a fraction. A number composed of a whole number and a fraction. An example is 3 1/2. Equivalent fractions. Two or more fractions that are equal. Two or more fractions that are equal. Okay, let's look at an example here on equivalent fractions. We have 2/3 Okay, let's start with 1/2. Let's start with 1/2. Okay, so let me show you 1/2 here. Now remember, I am working in the concrete and that I have an object in front of me that I can fold, even if it's a sheet of paper, in order to demonstrate 1/2. Okay. 1/2. Now, whenever you are working with a model of a fraction, they must be the same length and have the same area. So if I'm going to use a fraction strip, I have to make sure that they are all the same length. So I'll just cut 3 out. That's all I got out of one sheet of Post-it notes. Okay. Now this one, I'm going to fold it in halves and fold it again in order to get my fourths. Let's go ahead and show the markings here. So here I have 1/2, 1/2, 1/4, 1/4, and so on. And again, notice that I have them the same length. If I want to find equivalent fractions and I'm using a strip diagram, a strip fraction, they have to be the same length. So if I'm looking for what would be equivalent to 1/2, they have to be the same length. And so I would have a set of fraction strips for my students to work with. So 1/2 is equal to 2/4. So 1/2 is equal to 2/4. These are equivalent, and then I could show them my examples. Now, it might be a good idea here. I'm just going to glue part of it down. Let's see here. Yeah, I want this to be able to fold. How's that? And then my 1/2. Make sure they line up because we're trying to show the same length. As you're gluing them in your notebook, make sure they are equal in length and that they line up. There we go. And I could continue with other. What else could I do? 1/2 of 1/4 would be 1/8, and I could continue going. Of course, it gets to the point where these are very small. If I were doing this in my classroom, I would have a large set of fraction strips. So we're just using a tiny strip, and you get the idea. I'm only using the third one because I had already cut it. Make sure they're equal in length. So I have 1, 2, 3, 4, 5, 6, 7, and 8. Okay, which is equal to 4/8. Very simple. And this one has the glue, so it's going to want to glue down. But I have 2/4, which is equal to 1/2. And then 1, 2, 3, my 4/8. These are all equivalent to each other. The difference is the number of pieces. For example, if you get a slice of, if you buy a pie and you cut it in half, or you can get the same pie or pizza, you can do this with pizza or whatever, and you keep cutting the slices smaller and smaller and smaller, it's regardless, it's going to be the same size. Half, again, be careful with your drawings. Usually with our students, we would give them a sheet of paper with the drawings because it's very difficult, especially with the circles. You don't want the students drawing crazy circles where some are big and some are little. So these two have to have the same length, and these two have to have the same area, the same size, the same area. And this is 1/2. And this one is 1, 2, 3, 4, 5, 6, 7, 8. So 1/2 is equal to 4/8. Whether it's a fraction strip, I can use a model, a concrete model, something as simple as a sheet of paper. So here I'm doing models, and here I'm drawing a picture. So this is the concrete model, and here I am in the pictures level of understanding. So equivalent fractions are two or more fractions that are equal in length or equal in area. Okay, since we have some of our basic definitions down, how do we teach fractions? We have the linear model, area model, and the set model. Now the linear model is also known as the length model. So sometimes they'll use the word linear, or sometimes they'll use the word length. Okay, so let's go ahead and look at some examples of these, of each one of these. And we can go through and highlight these after we're done. I'll finish later. Okay, so let's look at fraction strips. Now, fraction strips could be something as simple as we did here, in which we cut out literally strips of paper, all the same length, but they do sell a set of fraction strips, plastic fraction strips, that are available for your students. Okay, so let's look at the length model. The length model of fractions can be associated to a number line. So there's my fraction strip. Number 1, the length or linear model. So can be associated to a number line. Or it could be a fraction strip. Either purchased, like I showed you earlier in the picture, or it could be something that you cut out yourself. Fraction strip. So let's look at 2/3. So 2/3 is 2 out of 3. Okay, so here's my strip. I divide it into thirds, and 2/3 would simply be shading 2 out of 3. So again, here I have my fraction strip. We could also look at a number line, and I'm going to make it the same length just to show. So here I have from 0 to 1. I divide it into thirds. So this would be 1/3, 2/3. And I could put, if you're doing the number line, I could put a dot on my number line, or I can shade this region. I shade this portion of the number line. So let's write this down. Fraction strip. Put a dot here. And the number line. Here I have an example of equivalent fractions using the strip model, which we did that earlier, in which I get a strip of paper and I could fold it in halves and have it in tens. This could be something that I pre-print, that I print out for the students, and then they could cut it out and glue it to their notebook. Number line. Let's go ahead and draw this picture because this is interesting. So here's another number line. Now remember that fractions are part of a whole. So you have to draw the whole number line from 0 to 1. That's my whole that I'm referring to. All fractions do not have to be the same length. They have to be the same length when I'm comparing them to each other. But here, this is another problem. I'm going to draw a number line, and I want to show equivalent fractions. So let's look at the 6 over 6. So probably should have made it a little bit bigger. So we're here in the center. So it's 1, 2, 3, 4, 5, and 6. So let's go ahead and label those. 1, 6, 2, 6, 3, 6, 4, 5, and this is 6 over 6, which is equal to 1. And I try to be as accurate as possible. Of course, my drawing is not perfect. Some of these are unequal. And again, with my students, I could have this pre-printed and they would just fill in the numbers. Okay, now let's do the same number line. And let's go ahead and identify thirds. Now you could draw it separately and then compare them, or you can do it on the same as I did there. So if I was doing this in thirds, again, I want to make sure it matches. 1/3 has to equal there, every other one. So this would be 1/3, 2/3, and 3/3. So which do you prefer, separate or together? I like the little pieces across the top. Let's redraw this one. Let's try it again. So starting in the center, so 1, 6, 2, 0, 1, 2, 3. Notice how we started with 0, 4, 5, 6. And then on top, every other one. 1/3, skip 1, 2/3, skip 1, 3/3. I think this one's a little bit harder to do because you have to know to skip every other one. Here, I could start off with two separate number lines and then combine them to show the students, look, 1/3 is equal to 2/6. They have the same length. Remember, we are looking at same lengths. So 1/3 is equal to 2/6. 2/3 is equal to 4/6. And we could even go all the way over here to 3 over 3 is equal to 6 over 6, which is equal to 1. We are looking at the same length. Okay, let's look at that again. Yeah, I think I like this idea better of the two separate. Let me go ahead and shade these so that they'll kind of stand out. Remember, they must be the same length. Probably with my students, I could use grid paper, graph paper, and then with the lines, and they could sit there and count them, and that might be a little bit easier. Okay, so this way, these two, make sure that they're the same length, right on top of each other, and these two are the same, and at the end. And then here, I combine them together. So this could be a third color. With practice, they could go here. Start off separate, and then with a little bit of practice, they could learn to combine it into one number line. I agree. I like the way they do it there with the little sheets of paper. So you could turn this into an activity. You could draw a large number line on your desktop or on the walls or on a sheet of paper, and then you give them the little square rectangles. You can give them the rectangles with the fractions, and then they could sit there and place it on the number line. I have seen this activity with clothespins. I don't know if you're familiar with when we used to hang our clothes outside in the sun, and so they have these clothespins, and you would put each one of these fractions on an index card, and then have the students go up to the number line, which is your clothesline or rope across the front, and they would hang the number across on the clothesline on the rope. So you could hand them a set of little cards, and they could write out their fractions. Good activity. So this could be an activity. Number line activity. Oh, let's just circle it. Okay, so we're always looking for ideas of activities. So draw your number line, yes, but as in the picture where you have the cards, you can turn it into a little game where they have to figure out where the cards go. Okay, the second method we're going to look at is the area model. In the area model, the fractions are represented as parts of an area or a region. Fractions are represented as parts of a region. They have to have the same area. They have to have the same area. So if you're drawing circles, then you would have to make sure. So let's draw this circle. Now the thirds are hard to draw. You have to I'm going to turn it around the other way. Kind of like a peace sign. I'm not off the center a little bit, but you get the idea. And there's my thirds. And if I want 2/3, then it would be 2 out of 3. I could do a square, let me see, thirds. I could do a large rectangle, 2/3. This would be the area model. Now I know this one kind of looks like the fraction strip, but it's more of a rectangle. Okay, let's go ahead and look at this problem. We'll copy it if you have room on the bottom or on the top of the next page. So use the area model to decompose 5/6 by shading the fraction model only using two colors. So I'm looking for 5, 6. I'm going to do a small rectangle here. One, two, three, four, five, 6. And shade any 5 of them. Doesn't matter. I think I'll do 2. Remember, yours will be different than mine. And 3. So what I'm representing here is there are 2, 6, and 3, 6. Equals 5 out of 6. 1, 2, one color, and then 1, 2, 3 in another color, and they give me a total of 1, 2, 3, 4, 5 out of 6. Okay. Is there another way? I think there's one more, right? Let's try one more. Again, excuse my drawings. Let's go ahead and color one of them. And then 4 of them. 1. There we go. So here's the second option. Here I have 1/6 plus 3, 4, 6 to give me 5, 6. So we're decomposing. We started off with 5 out of 6, and we got the 5 out of 6 and shaded them in 2 different colors. So you could have put 2, 6 plus 3, 6, or 3, 6 out of plus 2, 6, different combinations. Okay. Use the area model to find equivalent fractions. Or let's write it as identify the equivalent fractions. Hard to draw circles. Let's try. Make sure, now here I'm comparing the two, so they must be the equal size. Equal area or equal size. Okay, so whenever I do thirds, I think of the peace sign. Let's try that over here. 1, 2, 3, 4. I need one more. 1, 2, 3, 4, 5, 6. So let's count them. 1, 2, 3, 4, 5, 6. And in the first one, they shaded 2 out of 3. Okay. And I want to shade the exact same thing over here. Exact same thing. My numbering's off. This should have been 1, 2, 3, 4. It's okay. 1, 2, 3, 4 out of 6. Equivalent fractions. Do you want to redo it? Yeah, let's draw it without the numbers. Shade them in. And then we'll number. How's that? So our numbers won't be off. Okay. Now it's 1, 2. 2 out of 3. 1, 2, 3, 4. 4 out of 6. And now the numbers match. 1, 2, 3, 4, 1, 2. Okay, no big deal. No big deal. So 2/3 is equivalent to 4/6. And now the third model is the set model. In the set model, the whole is understood to be a set of objects. So in the set model, the whole is a set of objects. So 2 out of 3 circles are red. So here I have some counters. I could use blocks. And I have 2 of them are red. Okay. 2 out of the 3 circles are red. And let's do 4/5 or draw a model of 4/5 using the set model, the length, and the area model. And area model. Okay, 4/5. Let's start off with a set model. I have 5 objects and 4 out of 5. If I wanted to model that here, I would have 5 of them. 4 out of 5. 1, 2, 3, 4, 5. 4 out of the 5 are green. 1, 2, 3, 4. 4 out of 5. In the length model, I could do a number line. I could do a fraction strip. 1, 2, 3, 4. 1, 2, 3, 4, 5. And then I'm going to one, 2, 3, 4. So I could do a fraction strip for the length model, or should we label this one? Hold on, this one was a set model. Now I'm going to do the length model. There we go. So here I could do a fraction strip, or here I can do and related, or also do a number line. So this would be 0, 0/5, 1/5, 2/5, 3/5, 4/5, and 5/5, which is my 1. Okay. 2, 3, 4. Okay. And the area model. Now the area model, be careful, it does also looks like a fraction strip, only I would make it more like a rectangle. Draw a rectangle. 1, 2, 3, 4. 1, 2, 3, 4, 5. So it's very similar to this one right here. Let's try drawing a circle. That was not going to be as easy. Let's see if we can draw a circle. Maybe in pencil. it looks like here's my center. No, I said draw it in pencil, right? Let's try it again. I'm trying to draw so it's like a head with 2 arms and 2 legs. 1, 2, 3, 4, 5. So draw the head, the 2 arms going up, and then the 2 legs. I don't know, that's kind of what it reminds me of. Those are not equal, but you get the idea. 1, 2, 3, 4, 5. So this is an example where the circle is not the best option. Definitely not, unless you have these pre-drawn. But if you want your students to draw these, they're going to have harder time than we do. So in this case, a rectangle is definitely the better way to go. What was it? 4 out of 5. Okay, so this was a fail. This was better. So 4/5. Okay. Another definition that I'm throwing here at the end is a benchmark fraction. A benchmark fraction are fractions used to judge the approximate size of another fraction. Another way of looking at that, they are the easier fractions to memorize or to identify. Half, 1/4, 3/4. If you're drawing something like 5/6 or 7/8, those are not as common. And so the more easily recognized fractions would be 1/2, 1/4, so benchmark fractions. I'm going to put easy to identify. Example 1/2. But my goal, at least for today, was to get all our basic definitions out of the way as we continue to the next lesson. Let's go ahead and model an improper fraction. Let's look at those. For example, 5/4. So how would I model 5/4? So if I have let's go ahead and do a circle. 1, 2, 3, 4. Well, the only way I can get 5, if I go get another piece of pie, okay. So if I want 5 slices, I would get 1 whole one and 1 more. So let's look at that. So 5 out of 4. That would be all of these. That's 4, and 1 more makes 5. So an improper fraction is larger than 1. I needed more than 1 cake. In fact, I needed 1 and 1/4. So 5/4 is equal to 1 and 1/4. Here's my 5. It took 1 whole and 1 other one. Improper fractions. Let's go ahead and start to review our basic skills of fractions. I want to go to the back of our notebook, upside down to the back, and let's go ahead and practice a an addition problem. So let's go ahead and add 6 and 2/8 plus 4 and 5/6. Okay. The first thing we're going to do, anytime you add or subtract fractions, you must have a common denominator. So we need to find the common denominator. Or in this case, we're going to find the LCM of 6 and 8. If you remember, the least common multiple is used for our common denominator. So it's been a while since we've done this. There are two methods to find the LCM. We can use the factors or the list of multiples. I'm going to make a list of multiples. So find the common denominator or the LCM of 6 and 8 using the multiples. Okay, here we go. So we're going to multiply a couple of 6's, a couple of 8's until they match. So 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 6 times 4 is 24, and there it is. So my least common multiple is 24, and that is going to be my common denominator. So then the second thing I'm going to do is I'm going to rename the fractions with the same common denominator. So we are going to rename the fractions with the same common denominator. So we are adding 6 and 2/8 plus 4 and 5/6. Now my common denominator is 24. Go ahead and leave a space because we're going to need something here. So leave a space and put your 24. Now we're looking for equivalent fractions. 2/8 is going to be equivalent to a fraction that has a denominator of 24. It's the same fraction. It's like you have part of a piece of cake, the pieces are too large, and you decide to cut them into smaller pieces. Have you ever done that? Where you have a slice of cake, and you say, you know what, I'm going to cut it into even smaller pieces. So you're just cutting them and cutting them and cutting them until we have 24 slices. That's awfully small, awfully small. So what we're going to do is ask ourselves, how many times does 8 go into 24? Or 8 times what number gives me 24? So we know that 8 times 3 is 24. So 2 times 3 is 6. We are multiplying by 1. Or the way we used to say it is, whatever you do to the bottom, you do to the top. So 8 times 3 is 24. 2 times 3 is 6. These two fractions are equivalent. So 2/8